Okay, welcome back. Hopefully you've had a chance to take a look at the problem, finding the volume of an orange with a radius of 5 centimeters. Okay, so to generate the solid, it says, begin with a semicircle of radius 5, and then rotate that solid around the x-axis. So remembering your functions, this being a semicircle, you should be able to recognize that this function is the square root of y equals the square root of r squared, so r being 5, 25 minus x squared. So that's the first thing we need to do. And I do realize some of you might be thinking, well, the orange is just a perfect sphere. You know that spheres have volume. Maybe you don't remember this, but the volume of a sphere is 4/3 pi r cubed. And I always remember that because I know that the derivative of the volume is the surface area, which would be 4 pi r squared. So it just helps me remember that. You're not going to need to know that for this, but I just thought I'd throw that in there. Well, never hurts to have more information. So we've got this two-dimensional object that we're going to follow our instructions that we just learned in the last video on how to construct this so it makes sense. So the first thing it said was to sketch the graph. Well, that's already sketched for us. And draw a vertical line from the, let's see, what colors did I used to use? I think I like the red. I don't remember. I'll get back in the swing of things here. But we want to draw a vertical line from the curve all the way down to the x-axis, because we're going to rotate this around the x-axis. And then I'm going to actually draw a whole rectangle. Okay, so there's my rectangle. Now in order to know how far down I go, I want to reflect, follow part 2 here, make a rectangle, reflect the graph across the x-axis. And so that's going to come down like this. You go right through there. I may have mentioned in one of my videos that your success in this section really, part of your success depends on how well you can draw a three-dimensional object. So if we rotate this rectangle around the x-axis, then it would look something like this. Come down here like that. And then this part also go parallel. You get a lot of practice with this. And then, so that gets rotated around. That's kind of nice to have that shaded. That's the part you can see. That's the part that kind of comes towards you. Okay. And the other part is kind of behind. So you make that dotted. Okay, and same thing over here. Okay, that's not too bad. Okay, in fact, that actually is pretty good. I'm pressing myself here. Alright, so there's our disk, and now we just have to figure out what the volume of that disk is. Okay, well, remember, let's get some green in here. This line right here, that line right there, is the distance between the x-axis and the curve. So that line is 25, radical 25 minus x squared. Okay. Well, that's the radius, right? That's the radius of the face of our disk. And remember, that little distance right there, that's just our dx. Okay. So if we want to, let me do this over here. If we put the disk on its side like that. Okay, this guy right there, that's the radius, which we just talked about, 25 minus x squared, and that little guy right there is our dx. And so we know that the volume of one disk, why is it spelled with a C in one place and a K in another? Sorry, you can spell it either way. Volume of one disk would be area of the base, area of the base multiplied by the height. So if we're looking at the disk in this way, the area of the base is pi times the radius, which is radical 25 minus x squared, nice, multiplied by the height, which again is dx. That's the volume of one disk. Let's cruise on over here. And we want to go ahead and write down the volume volume of the orange. Okay, the volume of the orange would be the sum of all the disks. There's sum of the infinite number of disks. And what are beginning and ending points? Should have talked about that. Beginning and ending points should be pretty clear here. That's -5, and it's over here, it's +5. Okay, so that's where we begin and end. So the volume of the orange would be the integral from -5 all the way to 5, and we're going to find the integral of the volume of one disk. Okay, we're going to integrate from -5 to 5. So volume of one disk is pi times, and we can take this radical 25 minus x squared to the second power is just 25 minus x squared dx. Now, I'm going to go ahead and plug that into the calculator. I'm going to remind you of some little tricks here that I've learned. Okay, so easier to see it if I just clear it out. Okay, so the volume of one disk is, we already found that. We're going to integrate. First thing is, guys, here's the biggest thing students forget. They forget to put the pi in there. And in order to remember to put the pi in there, let's put it in as our y1. So type your integrand in as your y1 and then be done with it. So 25 minus x squared, that's pretty easy to type in. 25 minus x squared, but get the pi in there, and then you're fine. Okay, so you quit that, and then you do your math 9, and you want to integrate from -5 all the way to 5. You're integrating your vars y1 with respect to x, and you get your 523.599. Okay, 523.599. So let me write that down, but I also want to show you, we're going to confirm that that is in fact our answer. Okay, that's 523.599. And right, let's go back to that formula. Okay, remember the formula? Volume equals 4/3 pi r cubed. So this is really only going to work if you're dealing with cylinders. So most of the, in fact, every single one of the problems that you do from now on is not just going to be, sorry, I think I said cylinder, is not going to be a sphere. It's going to be some other kind of a shape where you have to use the calculus to find the volume. Okay, but let's just go ahead and type this in. 4 divided by 3, we're going to multiply that by pi, and I'm going to multiply that by r cubed. And r, remember, was the square root of, let's do this, let's put a parentheses there. Oh man, didn't mean to do that. 4 goes there, 4 divided by 3, and then we're going to do multiplied by pi, multiplied by the square root of 25 minus x squared. And I didn't mean to put that there, delete that. Okay, so that goes there. And that's raised to the third power. So if everything went well, that's exactly what we got before, right? No. Was I off a little bit? 3, 4 pi r squared. Okay, so I guess it's close enough. Not really close. I don't know what happened. I'll have to take a look at that. To the third power, pi r to the third, 25. Maybe you guys can help me out there. I don't know, but usually ends up to be exactly the same thing. So I don't know what happened. Maybe it's off just by a little bit because of some other reason. Maybe I need parentheses in there. Let me try this. And back up here, parentheses. I don't think this is going to help. I don't like this calculator. Delete that. Second insert. There. And I did it again. So maybe that's as close as we can get. Either way, we found the volume, and we'll get back to you. I have to get back to you after 6 o'clock. I gotta go.